Hello everybody, my name is Sorla Teschler. I am a research engineer working on a clean energy topic, and today we are going to do 3 experiments together from Celebrating Chemistry, Protecting Our Planet Through Chemistry. The first experiment is from page 5, recycling water. The second experiment is going to be from page 8, earth-friendly plastic, and the third experiment is drinkable yogurt raviolis, and the instruction of that can be found in your bags that you picked up from the library. So now let's go ahead and start the experiments. The first experiment is recycling water. In this experiment, we are going to find out if we can separate water from polluted water. For this experiment, you are going to need 2 different size transparent cups or plastic bottles. I use recycled water bottles. And you need one type of pollutant, which I have sand here, and that's what you received in your boxes. You also need some ice. I am doing another pollutant, which is a green food color. That's why I have another set of cups. I named my cups cup 2 and cup 1. Now I'm adding some hot tap water to cup 2. Do not add boiling water to cup 2 because some plastic would melt when they're heated. Now I'm adding some sand to cup 2 as a pollutant. And now I'm trying to fit cup 1 on top of cup 2. In cup 1, we are going to add the ice cubes and some cold tap water. So now we built our first recycling water system. I'm going to do the exact same thing for the second pollutant as well. Adding hot water to cup 2 and adding ice and cold water to cup 1. Here I'm adding the food coloring to cup 2, and that's our second pollutant. So after this, write down your observation in the table in the brochure that you received. Do you see any liquid in the bottom of cup 1? I do not see any in mine. Now we are going to wait 10 minutes and write our observation again. Now it has been 10 minutes since we started the experiment, and now we are going to write down our observation. So we have the system 1 with the model pollutant sand on the right, and we have system number 2 with the model pollutant green food coloring. Now we are going to look closer. And what is on the bottom of cup 1? I see some water droplet in the bottom of cup 1. I'm going to bring it closer so you can see better. there is basically no evidence of sand on the bottom of cup 1. And now we are going to look at our second system. I again see some water droplet formed on the bottom of cup 1. So I am bringing it closer, and basically there is no sign of that green food coloring on the bottom of cup 1. So now let's talk about what happened here basically. So in this experiment, we had evaporation and condensation. Does anybody know what those two words mean? So evaporation is the process of liquid water turning into gas, and condensation is basically the reverse process where water vapor becomes liquid water again. So in your experiment, water vapor rising from the hot water in cup 2 contacted the cold bottom of cup 1, and you observe condensation on the bottom of surface of cup 1 as drops of pure water. The liquid or solid pollutant that we added, basically you added sand and I added sand and food coloring, did not end up on the bottom of cup 1. Why not? So I tell you the reason. The pollutant need more heat to evaporate than water needs to form water vapor, and so they're left behind. So the interesting thing we did here is that with a very basic system, with simple system, we were able to separate water from its pollutant and get fresh and pure water. You can continue this experiment for another 20 minutes and write down your observation. Okay, before we get to the next experiment, I want to give you a very brief introduction about earth-friendly plastics. Humans use a lot of plastics. Our shoes, water bottle, toothpaste, snack containers are all made out of plastic. But have you ever thought what happened to these plastics after we're done with them? You may say that we recycle them, but yes, we do recycle them, but only 14% of plastics are being recycled. And it's predicted that if we continue using plastics with the same rate that we are doing today, by 2050, we are going to have more plastic in the ocean by weight compared to fish. And that's the reason for that is because these plastics are based on fossil fuels, and it takes them 100 to 1,000 years sometimes to degrade in the environment. But the good news is that chemists are already thinking about these problems, and they're trying to make more earth-friendly plastics or bioplastics that degrade faster. And one exciting new discovery is basically these eco-friendly water bottle called Oho, and these made out of seaweed, and you can basically eat the whole thing, or you can break it and drink the water and throw out the pod out in the compost bin, and it will degrade within 6 weeks. And these water bottle or water pods were actually handed out during the 2019 London Marathon to the people who were competing, and that reduced the need for 200,000 plastic bottles, which is great. And today we are actually going to make our own water pods, and if you want, you can actually try them too when you make them. Okay, now let's go to the experiment. So for this experiment, you're gonna need 2 bowls, different sizes. You're gonna need a bigger spoon to take the solution out. You're gonna need, I have 3 measuring spoons, calcium lactate, sodium alginate. I have a cup to measure water, and I also have a blender. I also do have a food coloring. It's not necessary, don't worry about it if you don't have it. Now I'm going to start the experiment by adding 1 cup of cold water to the blender. And then I'm going to add 1/4 of a teaspoon of sodium alginate to the blender. Then I'm going to add some couple droplets of the green food coloring to the mixture. There was no food coloring in your bags that you picked up from the library. Don't worry about it. It is totally optional. I'm just doing it here because it will make the pot look better in the video. Now I'm just blending the mixture for about 20 seconds or so till it's all dissolved. Those dark green dots are from the food coloring, so you're not gonna have that problem in your mixture. Now I'm going to pour it in one of the bowls. In the second bowl, we are going to add 4 cups of cold water. Oops, it looks like I ran out of water, so I'm just gonna go get some more. Now I'm going to add 1 teaspoon of calcium lactate to the water solution. And I'm going to mix it with a large spoon. It looks like it's all dissolved. So now I am going to fill 1 teaspoon measuring spoon with the alginate mixture, and carefully lowering it into the calcium lactate bowl so the solution covers the spoon. It's better if you let the sodium alginate sit in the calcium lactate solution for about 5 seconds before you remove the spoon. And after that 5 seconds, slowly turn the spoon over so the pot slides into the solution. Here I'm trying to make a second one. So the key here is just to be patient and slowly turn the spoon over and take it out of the water. I almost never got a perfect sphere, so don't worry if yours is not a perfect sphere either. Here I'm switching to a teaspoon or tablespoon, sorry, because I wanted to get slightly larger pots. So I'm gonna make a couple more here, but do not try to overcrowd the bowl. That one looked a little better than the other two. So making the pots take a little bit of practice. This is basically my third time doing this experiment, so I have a little bit of more of an experience. So you can try a couple times, and hopefully by the end you'll get a perfect one. I'm going to make one last one here, and I'm going to let the pot sit for 15 to 20 minutes. Now it has been about 20 minutes since we've left the pods in the calcium lactate solution. And now I'm going to take the first one out. But it looks like that definitely the pods form. It's not a perfect sphere, but it definitely looks very interesting. Since this one does not look like a perfect sphere, I'm going to try to take another one out. Wow, this one looks much better. So these pots can be squished open to observe the properties. It's just going to be water in them, and if you squish them, the water is going to come out. And also they're safe to be eaten. I actually tried mine. It tastes a little bit bitter, but it's not that bad. So go ahead and try them if your parents allow you. So now let's talk about how it works and where the chemistry is. So sodium alginate comes from a type of seaweed, and it is made up of a long chains of repeating molecules similar to necklaces. When sodium alginate is placed into calcium lactate solution, a chemical reaction occurs where the calcium and sodium switch places. The new calcium alginate is different from sodium alginate because now the long link chains begin attaching to each other, a little like a chain link fence. This is called crosslinking. And in our experiment, the connected strands of calcium alginate form the jelly-like outside of the pod while the water is trapped inside the pod. For this experiment, we are going to need 2 bowls, measuring spoon, a bigger spoon, yogurt, sodium alginate, calcium lactate, and a blender. So in this experiment, I'm going to first add 1 cup of cold water to the blender, and then add 1/4 of a teaspoon of sodium alginate to the water in the blender. If you still have some of the solution from experiment number 2, go ahead and use it. You don't need to make this mixture again. But mine, if you remember, had some green food coloring in it, and that's why I'm starting over. Now I'm going to blend the mixture exactly like what we did in the previous experiment. It looks like it's all dissolved, and those are just bubbles, which they're gonna eventually go away. Now I'm gonna pour it in one of the bowls. Now in the other bowl, mix the yogurt that you have with 1/4 teaspoon of a calcium lactate. So now I'm just adding the yogurt. And then I'm going to add 1/4 of a teaspoon of calcium lactate to the yogurt mixture. Now I'm going to mix them with a spoon. Now using a 1 tablespoon measuring spoon, I fill some yogurt in the spoon and then carefully lower it. I'm lowering it into the sodium alginate bowl so the solution covers the spoon. This is very similar to what we did last time. When we lower the spoon, leave it there for about 5 seconds and then slowly turn the spoon over so the pot slides into the sodium alginate solution. Now I'm going to make a smaller one using a teaspoon measuring spoon. So if you notice, we are basically doing this process in reverse. So in the previous experiment, experiment number 2, we added sodium alginate solution to the calcium lactate, and here we are just using the yogurt that had a calcium lactate to the sodium alginate solution. The chemistry behind this is the same. It's the cross-linking between the sodium alginate and calcium lactate, but it's just the order is different. And this process works better if you're using something denser than water, something like yogurt or like dense juice or milk. It would be better to do it this way. So now it's been 10 minutes since we left the pot in the sodium alginate solution, and now I'm going to take them out using a big spoon. Be careful when you're removing the pods from the spoon. There's a chance that you break one. So as you can see, the pods form perfectly and the yogurt is trapped inside. I'm going to take all of them out and put them on a paper towel. Oh, did you see that? So I broke the pot while I was removing it, so that's why the yogurt inside basically came out and it's just got into the sodium alginate solution. So if you're not careful while you're taking them out, this might happen. But it's okay, I still have 2 other good ones. I'm gonna break one here so you can see what happens when we intentionally break one. And now we're going to look at the pods and then see how the pod itself look like. It basically looked like a jelly, clear jelly. So these are, again, safe to eat. And if you're a parent, allow it, just go ahead and try them.